All right, next topic is looking at solving when substitution is required. And really what we're given is effectively a quadratic, but we've got to recognize it as a quadratic and then turn it into one so we can solve to find what possible values could P be and for this still to be true. So step one is we're going to substitute x into the equation. Well, after we substitute x, we're going to factorize and solve. So let's do that now. So let's having a look at this. What evidence do I have where an x could be? Well, this is 2 to the power of p. This is 4 to the power of p. So really, this could be an x. Let's call that x for a moment. And if we call that x, this would be nicely x squared, because we know that 2 to the power of p times 2 to the power of p is 4 to the power of p. So that kind of works out. And this is just 2 to the power of p, or if you like, x to the power of 1. So let's rewrite that now. Let's restate it in terms of x. So this is x squared minus, well, 7 lots of x minus 8 is equal to 0. Now, of course, step 2, we can factorize and solve. So let's go ahead and factorize and solve the equation. Well, nice simple one to do. We know that we've got an x and an x of some sort. Signs are different. The biggest of the numbers in here, the biggest factor is going to be negative. Factors of 8 are 1 and 8, 2 and 4, but only 1 and 8 can subtract or add together to give 7. So 1 and 8 must be the result. The factors, the biggest one is going to be negative. Biggest one is 8, negative goes there, 1 goes there. So if this is going to equal 0, then either x is equal to -1 or x is going to be equal to 8. Sorry, you can't see that. All right. So we're on the scoreboard now. We've got two numbers, but now let's go back and we're going to equate x to p. So 3, we're going to equate x to p. That's what we're going to do. So rather than writing an x here, we could just write a p there. And of course, we know that we said that x was in fact 2 to the power of p. So rather than writing an x, let's write a 2 to the power of p. So we could say 2 to the power of p equals -1. Is that true? 2 to the power of p equals 8. Does that work? Well, there's nothing we can make p equal to so that the answer would be a -1. It wouldn't work. You can't find the logarithm of a negative number, so this is not going to play out. However, 2 to the power of p equals 8. Well, we know, for example, 2 to the power of 3 equals 8. So really what we're saying here is p could be 3. There it is. When I say could be, notice that was step 3. Step 4 is we're going to check, yeah? We're going to check by resubstituting the value of p into the original equation and see if it actually works or not. So here was the original equation. It was 4 to the power of p. Again, you can't see that, sorry. 4 to the power of p minus 7 times 2 to the power of p minus 8 was equal to 0. So I'm going to make p equal 3. Here it goes. So I got 4 to the power of 3 minus 7 times 2 to the power of 3 minus 8 is equal to 0. Now 4 to the power of 3 is 64. 2 to the power of 3 is 8. 7 eighths are 56. And I've got a minus 8 on the end. Is that true? Well, 64 minus 64 is indeed 0. Therefore, we can state that p equals 3 is a solution. And that is our answer. Whereas p equals p being, there's nothing p can equal to be -1, so x can't be -1. P has to be 3, and that is the answer we're looking for.